So yeah, as you know, I'm going to talk to you about Dockerising JavaScript applications. A bit about me, I work at Nexmo. We provide APIs for you guys to send SMS, to do voice calls, to do verification via SMS and like Facebook messages, anything you can think of communication, we can do it. I wrote a book. It basically guides you through how to do TDD, CI, containerization, orchestration from scratch. So you build a very simple application, and it uses all these tools to help you make it very robust. You can buy it here. I don't have that much money, so any royalties is cool. So what are we going to go through today? So first, we're just going to build a very simple application. We're going to deploy it the traditional manual way. And then we're going to discuss what problem this poses. And then I'm going to introduce you to containers and Docker and deploy the same application using Docker. And then we're going to look at what problems this solves. And the second half, the last 10 minutes of the talk is going to be about optimizing the Docker image. So this is the application we're going to be building. So basically it has the front end, a back end, and a database using Elasticsearch. In the front end, it's basically just a text area. You press a button, it generates a JSON object. You submit it, it goes to the back end, which saves it in the database. So this is how you would deploy it manually. First, you have to install Node. Then you have to install Elasticsearch, which is based in Java, which is it's based in Java. And then you download the repository, run the installation script, and then run your application. So this is what you have to do. So first, you have to start Elasticsearch and get the password right. And then you run the front end. I don't have internet, but it should be cached, I hope. And then you run the back end. So to make sure that it works, let's send a curl request to the back end. And it should just return with a JSON array of all the objects that we have. And then if we open the browser, we can see that the same object is there. We can generate a new one, submit it, and we go back to the back end. Can't read it. And we curl it again, and you can see it's updated. So basically, this demonstration just shows that the front end can talk to the back end, can talk to the database. So what was wrong with that approach? First, there's a lack of consistency, right? It works on my machine because I use Linux because it's good. But then if you give it to like other people, they use Mac for some reason, and then it doesn't work. So that's a problem. Lack of independence. So my application uses Elasticsearch, right? What if I have two applications? One uses Elasticsearch 6.3.2, and then another one uses 6.4.2 or something, right? Do I have to change the path or like uninstall and reinstall Elasticsearch to work on different projects? That sounds really backwards. It's time consuming. I did a lot of installation before already, but if you have to do it from scratch, installing Node, installing Java, that's going to take at least 10 minutes, even if you do it every day. It's error prone. I'm so glad I didn't make a mistake, but like in the previous run, I made lots of mistakes because I'm human and everyone makes mistakes. It's difficult to maintain. Right now, it's only in the development environment. What if you have one in production, in staging? You shouldn't have staging, but if you do, staging, playground environments. And then if you want to upgrade a piece of software or a library, you have to do that for every single environment, and that's going to be a hassle. Right now, I'm running it on my machine, or you can run it in a server. And if the server goes down, everything goes down, right? And lastly, we version control everything. We version control our application. So why don't we version control our deployment as well? So this is where container comes in. Containers are a method of virtualization. It's kind of like you have this little kind of confined space, and then you can run everything inside it. If you're familiar with virtual machines, it's kind of like that, but a lighter version of it. It uses Linux containers, which is like a feature that is built into the Linux kernel like just over a decade ago. And internally, it uses C groups and namespaces. So all that does is it groups processes together, and then it packages resources like memory, CPU, time, and process IDs. It packages all that stuff in, and then it presents to this group of processes. And from the viewpoint of these processes, this packet of resources is all you can see. So even if my computer has 24 gigabytes of RAM, which it does, if I just present 4 gigabytes to my container, you can only use that 4 gigabyte of RAM. And what you can do with containers is you can package everything, all your dependencies inside a container, so that when you run your application, all you have to do is run the container. You don't have to install any additional libraries. So this is just a diagram I got from somewhere. I should really attribute the image, but I didn't, of the difference between running applications on your machine versus in containers. So what is Docker? People think Docker is a container format, but it's not. The Linux container is a feature that was only implemented 10 years ago. So in the grand scheme of things, it's quite new. So Docker is not trying to reinvent the wheel. All it does is provide a standard way of defining and running the containers. So for defining, it has the Docker file format. If you use that format, you can use Docker build to build any image using that format. And if I have a Docker image, I can give it to you, and as long as you have Docker installed on your machine, you can run that image as well. So it's just a standard way of doing things. It also provides an ecosystem, so it has Docker Hub, which is like the NPM registry for Docker images. You just upload your image on there. If people like it, they will use it. So how do you work with Docker? So before, in the manual approach, we run everything on the command line. With Docker, you specify all your commands in a Docker file. So instead of running npm install in the command line, you add a line in your Docker file to say run npm install. Then you use the Docker CLI to build the image, and all that does is it goes through each line of your Docker file, and line by line, it will build up a layer to build up your image. So at the end of the build, the image is basically what would have happened if you run it manually anyways. And then you use Docker run to run your image. So let's go back to our application and see how we can deploy it using Docker. And as you can see, like all you need to do is Docker build and Docker run. So instead of running all the node installation script yourself, you can just pull in one that is already made for you from the Docker Hub. The same thing for Elasticsearch. You don't need to do anything, just pull it down. And yeah, I'll show you how to do it in my other workspace. So I'll ignore that. So I pulled the image beforehand. Yeah, okay. This is the cleanup step, which I haven't run. Right, so everything I did before was finished, and I'll run it again. Again, I don't need to set anything up. Oh, because I'm already running it. This is why you don't do live demos. It's better when you're drunk. Okay. Right, so I don't have to do anything. I just pull down the image and I'm running it. Docker pull and Docker run. Again, for the backend, I don't need to do anything. Just pretend the network is working and you're pulling it down. So again, it's just docker build and docker run. Right. Same thing for the front end. Docker build and docker run. If we curl again, this time, because it's a new container and everything, it's an empty array. If we go to the browser, we generate something, we submit something, it should come back on the back end. So basically, everything we did before, we just did it again, but with containers, and it wasn't very hard. It was just docker build, docker run. So why is this better than our previous approach? It provides consistency through portability. Because the Docker image can be run anywhere that has Docker installed, if it works on my machine, it will work on your machine. It provides independence. If I want to run multiple instances or different projects using different Elasticsearch versions, I can just have 2 different Elasticsearch images. It saves time and it reduces error because I take the human side out of it. All I have to do is docker build, docker run. So all the logic of the deployment is specified in the code. It's easier to maintain. Editing a Docker file is much easier than going into every single server and running the upgrade. It doesn't eliminate downtime, but as Beth and, sorry, I forgot the other IBM people, as they've said, like for you to use like orchestration tools like Kubernetes, then you have to kind of containerize your application. So although containerizing your application doesn't eliminate downtime, it allows you to later on deploy your application on a cluster which will eliminate downtime and ensure high availability. Last but definitely not least, it allows you to version control your deployment process. So it can be a collaborative process, and more people can keep an eye on it and make it better. I don't know how much time I have, but I don't care. So the last 10 minutes is going to be about optimizing your Docker images. So this is the one, I'm going to pick the front end because it's easier to demonstrate stuff. So this is the Docker file we have at the moment. Basically, it's just copying everything into the container, installing it, building it, and then serving it. So the first thing you should know is that inside a Docker file, you can specify a command using 2 different syntax. The first is a shell form, which is what we have already, and then the other one is the exec form, which is this. So the difference between them is when you specify it using the shell form, Docker will run first a shell, and then it will use that shell to run your command. With the exec form, it will execute your command directly as the first process with PID 1. So why does that matter? It just seems like we saved one process and uses slightly less memory. It's not really important. What's important is the signaling. So the PID 1 in any PID namespace or on your machine has a special role. It's the first process, so if it shuts down, every other process gets killed. So when we run docker stop, for example, what the Docker daemon does is it sends a sigterm signal to the PID1 process, which is the shell. The thing is with this, the shell doesn't do anything. It doesn't propagate the error. It doesn't propagate the signal onto the npm or the node process. It just sits there. So you can see here, if I try to run docker stop on this shell form, this image that was built using our current Docker image file, it takes 10 seconds for it to shut down. And that's because after it receives a sigterm signal, it just hangs there. And Docker waits for about 10 seconds until it gives up and say, you're not doing anything, let's kill it with a sig kill. And if you sig kill a process, it cannot handle it, right? Because sig kill is done by the kernel. And so your process exits ungracefully and uncleanly. It cannot clean up after itself. If you use the exec form, however, the sig term is sent to the PID1 process, which in this case is the npm process. And Node has default signal handlers. And so this will shut down like immediately almost. And so instead of waiting for 10 seconds for it to stop, it takes just half a second. So now we're using the exec form. What else can we do? So a lot of us run our serve script using npm scripts. And what that does is npm runs, and then it spawns a subshell, which then runs your actual application. So the first two processes it's not actually needed to run your application. And if we look at the amount of resources they use, it's about half of what is being used in the container. So I did some calculation, and it takes about 52 megabytes to run the npm sh and node commands. However, if we just run the node, if we just run the HTTP server directly, then only that process is run in the container. And that only takes 36 megabytes. So it doesn't sound like a lot, but if you're running thousands of these containers all the time, then that can be like hundreds of gigabytes of RAM. Next, as Beth mentioned, Docker caches the images when you build them. But it can only do that up to the point where it sees a difference. So let's say we make a small change in our repository. Let's just like a typo change. I spelled generate wrong and want to spell it right. So in our current version, because in the copy instruction, Docker noticed something has changed. So it will invalidate the cache for all the subsequent steps. And it can only make use of the cache in the second step, which is a very light step. So basically, it's building everything from scratch. And 10 seconds is how long it takes. And this is using like the 1 gigabit connection in my office. And if I try to run it in my home network, it would take about 30 seconds or a minute. So that stuff is not good for development. So instead of copying everything, we should just copy what we need for the next step to run. So for npm install, we don't really need the source code, so we'll just leave it out. We just need the package.json and the package log.json. So now Docker can cache more things. So instead of running npm install again, which is arguably the longest process in the whole thing, it can just skip that step and use the cache instead. And all I have to do is run npm build, which still takes some time, but we went down from 10 seconds to 3 seconds. Next, removing obsolete files. So right now, our Docker image is 704 megabytes, which is huge. But if we go inside the container, we can see that a lot of the stuff is not actually needed, right? We've built our application. We don't need the source code anymore, right? We don't need this npm cache anymore. All we need is the thing that's highlighted in red. So how can we remove everything else? A naive approach would be to add a new layer to remove unnecessary files. But if we do that, we'll see that the image didn't decrease in size. And that's because each layer in the Docker image is a diff from the previous layer. So if the file is already inside the image, you cannot really delete it. Any layers you add on top of it is going to add to the file size of the image. So another naive approach is to have the installation script, the build script, and the cleanup script in the same step. And that does reduce the file size of the image, but then it also undoes all the caching stuff we've done in the previous step. So what Docker, I think, last year has done is it allows for multi-stage builds. So in a multi-stage build, you have you can have multiple from instructions inside the same Docker file. And each from instruction defines a new stage inside the Docker file. And you can copy artifacts from previous stages into your stage. So here we're just building everything and deleting the files we don't need. We're not actually going to use that image. We're just going to use this image. And we're just going to copy stuff from the previous stage into this stage and running our application. So here we have all the benefits of caching. We have, our Docker file is still very readable, but our image has reduced in size by 10 megabytes, right? So the last step, 694 is still pretty big. So, and that's because underneath the hood, the node image, the node base image, is based on Debian. And it's not just the Debian image. It has all these build dependencies and build tools. And it adds up to about 674 megabytes just for the node itself. So instead of using Debian, which itself is 101 megabytes, we can use a lighter version of Linux, which is 4.41, and that's Alpine Linux. And that doesn't have all the build tools. It doesn't even have Bash, but it's much lighter, so 770 instead of 674. So all we have to do is basically specify a different tag to the node image. And that will reduce the size from what we had originally, which is 700 and something, to 90.3. So that's like some very basic optimization steps. There's a lot more we should do. And one thing we definitely need to do is to make sure the container is secure. Even inside this optimized Docker file, we're running everything as root. And you should never run anything as root. So the next step would be to secure your container by using a non-privileged user. There's lots of tools online that helps you audit your container and find steps you can optimize, but that's for another talk. And just to put everything back into perspective, if you do want to make use of all the cloud-native stuff, like Kubernetes and Prometheus, then the first step is containerization. This is a trail map published by the Cloud Native Computing Foundation, the CNCF, and it basically guides you through the steps you should take to make your application cloud native. And yeah, first thing is containerization. The second step is CI/CD. If your test doesn't work or you don't have confidence in your test, then doing orchestration is going to be painful because you're going to deploy something, it's going to fail, you don't know why. So CI/CD comes before orchestration. And then once you have orchestration, you should observe it so that when something goes wrong, you know how it goes wrong. But everything begins with containerization. So containerize your application. Lastly, my book talks about Kubernetes and Docker and stuff. So here's the link. Thank you.